In this last example of factorization of polynomials in C, we're going to make use of the factor theorem. Now, what we want to do is we want to find a value of z so that if I substitute in there, my function equals 0, because that means it's then a factor of my equation or of my expression. So the easiest way to do it, or the normal way to do it, is to start off by using 1, -1, 2, -2, 3, -3. So we'll substitute that in until we get a value that is 0. Now, if your answer is x plus 10, it means you're going to do it 20 times before you get a value. So there must be an easier way. Now, on the question, they say use your CAS calculator. We're not going to use the CAS calculators. It won't be in the exam. You can use the calculator, though, to check your answer. But I want to show you how to do it manually. So if you don't want to guess, use your calculator. This little green calculator, switch it on. Works much better that way. What we do, we press on table. And if there's already an equation, I'm just going to clear that equation. And I'm going to start with my equation. And instead of using z, I'm going to use x. So I'm going to say this is x to the power 3, come out, plus 7x squared plus 16x plus 10. I'm going to press enter. I'm going to say start at, it doesn't know where you start at 0. Step 1, which means we're only going to go 0, 1, 2, 3, etc. Enter, enter, enter. Now what I'm going to have here is a list, and I'm just going to bring it up so you can all see. What I have is a list when x is 0, y is 10, when x is 1, 34, and I'm looking for a value where y is 0, and I see it's going up and up and up. It means I have to go in the opposite direction, and I say, oh, when x is -1, y is 0. So that's then my answer, which means if f is -1, then this equals 0. Now, my factor theorem say that if f equals -1 is 0, therefore, and it means that x plus 1 is a factor, because that is where x equals 0. So x plus 1, this is the opposite of that. If that was -2, this would have been plus 2. If this would have been plus 5, this would have been x minus 5. So it means x plus 1 is 0, which means it is a factor. Now, it also says then that if I have f at z, it says if I have f at z equals x plus 1 is a factor, then this times a new equation. Let's make that q to the power z, or qz in the function z, where this function is 1 degree smaller than that, which means it must be in the square. What does that take me to? It then says that I can say fz equals, and I know x plus 1 needs to be there. It's not x, this is z. Z plus 1 multiply, and now I'm going to have a quadratic equation. So it means that z times a z square must give me, plus there's going to be a z, plus there's going to be a, so it's going to be a quadratic equation. If that's a cubic function, this is a quadratic equation. If that is a to the power 4, a quartic, then this will be cubic. I just have to find out what's the other values now. And I'm just going to cross-check. I know that z times z square is z cubed, and I know plus 1 times something must give me 10. So this is obviously going to be 1 times 10. The middle one can be a little bit tricky, and there's two different ways of doing it. You can either look at your z values, your z square values, or you can look at your z values. I find the z value is easiest because z times 10 is 10z, so 1 times something z must give me 16. So if I have 10 z's there, so 10 z's over there, something z must add up to 16, which means that this must be there for is 6. So z squared plus 6z plus 10. And that I know then is my equation. So we know this is a factor and this is a factor. But the question says find all factors, which means we have to simplify this further. There's nothing in front. 10 and 6 we can't get there by using brackets, which means we will complete the square. Z plus 1. And for this one, I'm going to say that is z squared plus 6z. And I'm going to there say the bracket around, and I'm going to say plus 10. I'm going to say plus 6 divided by 2 squared. If I add that, I have to subtract it again. So that's going to be 6 divided by 2 is 3. 3 squared is 9, so it's going to be minus 9. And I'm going to just complete the square. Z plus 1, this is going to be the difference of 2 squares. Sorry, this is going to be z squared plus 6 divided by 2 is 3 squared. And this is going to be minus 9 plus 10, which is going to give me plus 1. Plus 1. This is not the difference of 2 squares. So what I'm going to do, this is not z squared. This is z plus 3 squared. Now I want this the difference of 2 squares. So I'm going to change the 1 to minus I squared. So this is going to be z plus 1. This is going to be z plus 3 square. And I'm going to make plus 1 minus I squared. Now this is the difference of 2 squares. The difference of 2 squares will be z plus 1. Difference of 2 squares is z plus 3 minus I, z plus 3 plus I. So this will be then all the factors of my equation over z, or over c.